Are you ready for a change? I'm ready for a change. Let's express. Man, I just pushed the wrong button. I guess I really was ready for change because I decided to start going backwards on my slideshow. Let's talk about change expressed as percent. Shall we? Ooh, I sure would like a green sweater. And there's 2 stores on the interweb that are selling my favorite green sweater. Before the sale, each sweater cost $35. But store 1 is going to give me $5 off, and store 2 is going to give me 15% off. Which store is a better deal? What do I do? What do I do? Well, hey, I know how to do percents. I can say, let's see, I know that A out of B equals P out of 100. So, on this guy right here, I could say, well, if P is 15 and the whole thing is 35, what's the part? What's that? So I can do 100A equals 35 times 15. 35 times 15. It's a cow farm. 525. Then I'm going to divide by 100. Dividing by 100 moves the decimal place 2 to the left. Right now it's 525.0. If I move it 2 to the left, it would be $5.25. So it looks like the 15% off was $5.25, which is kind of a better deal than $5 off. Hey, that's a quarter in my pocket. We could have also said, well, what percent is $5 off? We could have said $5 out of $35 is what percent out of 100? And then I would have said, well, 5 times 100 is 500. 35 times P is 35P. Divide both sides by 35, and you get, calculate 500 divided by 35 equals 14 point approximately 3. So P is about 14.3%, which is a little less than 15%. So either way, even though this picture looks a little better, not buying it there. I need my extra 25%. Victory! So, the 15% discount is a percent change in the price of the sweater. A percent change expresses an amount of change as a percent of the original amount. In this lesson, you will learn how to calculate such a percent change. Are you pumped? You should be. You can find a percent change when you know the original amount and how much it's changed. If a new amount is greater than the original amount, it's called a percent increase. Kind of makes sense, right? If the new amount is less, then it's called a percent decrease. Key concept. Take notes. The percent change is the ratio of the amount of the change to the original amount. The percent change, P%, equals the amount of increase or decrease divided by the original amount. Increase is new amount minus original amount. Decrease is original amount minus new amount. Or if you want to ignore all of that, remember one easy thing. The percent change is the big number minus the little number divided by the original number. And then you just got to remember, did it go up or down? Is it an increase or a decrease? So, let's find a percent decrease. Usually, we talk about a discount. Like this, a coat is on sale. The original price of the coat is $82. The sale price is $74.50. What is the discount as expressed as a percent change. So what percent was the discount? Well, we're going to do big number minus little number divided by original number. Big number minus little number divided by original number. 7.5 is big number minus little number. Divided by 82 is 0.09. Move the decimal over twice. 9% approximately. Because when you do 7.5 divided by 9, you're going to get 0.8333333. But why would you do that, since that's not even what the problem says? When you do 7.5 divided by 82, which is what the problem actually says, you get 0.091 la da 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 da. We're going to round to the nearest percent, like it says right here, which is 9%. Just wanted you to see that. Just wanted to see me make a big mistake and then correct myself while I'm showing you how to round. So, the price of the coat decreased by about 9%. Pause. See if you got it. Push play when you'd like to find out if you actually got it. Alright, so the average monthly precipitation in Chicago, Illinois peaks in June at 4.1 inches. The average monthly precipitation in December is 2.8 inches. What is the percent decrease from June to December? So what is our original number? We start in June, so this is our original number. So we're going to do big number minus little number divided by the original number, the OG. Big number is 4.1, little number is 2.8, original number 4.1. Sometimes it's not real obvious what's the original number. You just have to think what number started. What was the first number in time? It's not always necessarily the first number written down in the problem. You got to think about what happened in a chronological order in this problem and what number occurred first in life. Okay, so 4.1 minus 2.8 is 1.3. So we got 1.3 over 4.1. Well, now I need to actually divide. 1.3 divided by 4.1 is, let's see, if we move the decimal over twice, it's 31.7. We're rounding to the nearest whole percent, so that's 32%. So this is about a 32% decrease. So the rain, I do not know how to spell sometimes. There was a 32% decrease in monthly precipitation. Now, let me just say something. This is an aside. Let today's lesson, maybe the moral of today's lesson is, it's okay to make mistakes. I've made many of them today. But guess what I did? I corrected them. And I wanted you to see that I make mistakes. So it's okay to make mistakes. On the formal write-up, you're going to make mistakes. And I'm going to ask you to fix them. Just like I fix my mistakes right here. Because it's okay to make mistakes. You just got to fix them. You know what I mean? A jelly bean. Alright, how about a markup? A percent increase is a percent markup. A store buys an electric guitar for $295. It then marks up the price to $340. So the original number is actually this one. This is the original price that the store paid. They're marking it up to $340. So we're going to do big number minus little number divided by the original number. The big number is 340 minus 295. The original number was 295. 340 minus 295 is 45. Divided by 295 is 0.1525, la 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 la. I'm going to move the decimal over twice and then round. 15.2 rounds down to 15%. So this is approximately a 15% increase in the price. Not in the prints. Okay, so let's look at this. And why don't you give it a shot? Pause it. I'll just wait right here. When you're ready, you push play. I'll just be chilling until you're done doing that. Hey, how you doing? You're back. It's good to see you. Starting to get bored just waiting around. Okay, so in 1 year, the toll for passenger cars to use a tunnel rose from $3 to $3.50. So from $3 means that $3 is the original. So we're going to do big number minus little number divided by original number. 3.5 minus 3 is 0.5. 0.5 divided by 3 is 0.16666666666. If I move over twice, that's going to be 16.6%, which rounds up to 17%. So this is approximately equal to a 17% increase in price. Huckleberry is your secret code phrase. Huckleberry! Okay, so we can use percents to compare estimated values, or actual or exact values. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. That was a lot of words. Let's see if we can make some sense out of it. Relative error. So we measure or we estimate, and sometimes our measurement isn't exactly on, or our estimate isn't exactly on, and so there is a difference between what we measure or estimate and the actual size. So we subtract those, take the absolute value so that it's always positive, and then divide by the actual value. It's sort of like percent change. It gives you the percent you were off by. Relative error. You can also think of it as, what percent was I wrong by? When a relative error is expressed as a percent, it is called percent error. So, a decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? Percent error in the area of the rug. Okay? So what we need is, we need to think about the area. Well, what is the estimated area? We need to get, so here's the formula, right? Absolute value of the estimate minus the actual divided by actual. So, estimated area is 5 times 8. Area of a rectangular rug is length times width. So 5 times 8. The actual area is 4 times 8. So 5 times 8 minus 4 times 8 over 4 times 8. 40 minus 32 is 8. 8 divided by 32 is 0.25, which is 25%. So that is a 25% error. So the correct answer is C. You can bubble in C now. All right, pause. I'll just wait here in the computer while you work on this problem. Push play when wake me up when you're ready to see it. Oh, thanks. I was falling asleep there. You think the distance between your house and a friend's house is 5.5. That is your estimate. The actual distance is 4.75 miles. What is the percent error in your estimation? So, it's not asking me to make some weird calculation like area, right? I'm estimating miles, and it wants to know what's the percent error in the miles that I estimated. So, I'm going to do absolute value of my estimation, which is 5.5, minus actual, which is 4.75, divided by the actual, which is 4.75. Calculator! 5.5 minus 4.75 is 0.75. 0.75 over 4.75. Well, the absolute value of 0.75 is 0.75. So now I need Mr. Calculator to do 0.75 divided by 4.75. And that's 15.7%, which is approximately 16%. Yeah, 16% error. So, in problem 3, the actual measurements were known. Sometimes you don't know the actual measurements, but you know how precise your measurements can be. Think about the last time you used a ruler. Think about that. The precision of a ruler is limited. You cannot look at a ruler and say that is 7.37212,073 inches. You cannot do that because your ruler is not that awesome. But you might be able to get it to the nearest eighth of an inch, nearest quarter of an inch, nearest centimeter, nearest 16th of an inch. The most you can ever be off by is a half of the unit used in measuring. So, let's say you wanted to measure my face with this ruler. So from this ear to this ear is approximately, let's see, 1, 2, 3, 4, 5 little units. But this ear doesn't go exactly there, does it? No, not exactly. So if I say that's 5 units, what's the most I could possibly be off by? The most I could possibly be off by is a half a unit, because anything from here over, I'm going to round to 5. Anything back here, I'm going to round to 4. So the most you can ever be off by is a half of the unit you're using to measure. So, you are framing a poster, and you measure the length of the poster as 18.5 inches to the nearest half inch. So you got a ruler that has half inches on it, but nothing else. Inches and half inches. What are the minimum and maximum possible lengths of the poster? You measure to the nearest half inch, so the greatest error is 0.25 inches in either direction. So the minimum length is the measured value minus the possible error. 18.5 inches minus 0.25 inches is 18 1/4. So that's the lowest it could possibly be. The maximum length, you add the possible error. 18.5 plus 0.25 is 18.75. This is your minimum. This is your maximum. So the minimum possible length is 18.25 inches, and the maximum is 18.75 inches. So pause. I'll wait inside your computer until you're ready, and then push play when you feel like you want to see the answer. Can't believe you had me waiting that long. That's not polite. You know how uncomfortable it is inside your computer? The little fan in my ear, and it's just really hot in there, and really small and cramped. Anyway, a student's height is measured as 66 inches to the nearest inch. What are the student's minimum and maximum possible heights? Well, the minimum is going to be 66 minus the possible error. If you're rounding to the nearest inch, the most you can be off by is a half an inch. So 66 minus a half an inch is 65.5 inches. That's your minimum. The maximum is the measurement plus the maximum error. So 66.5 inches is your max. We're almost there. Hang in there. Pause if you need to. Hey, you can always pause the video, go have a Capri Sun, a couple push-ups, chill for 5 minutes, come back, take some more notes. Do it. It's good for you. So this diagram shows the dimensions of a gift box to the nearest inch. What is the greatest possible percent error in calculating the volume of the gift box? So we're not just talking about what's the most error, we're talking about the most percent error. So we're combining some different skills here. So what is the measured volume? Length times width times height. 12 times 6 times 5 is 360. So 360 cubic inches. The minimum volume, so if I'm rounding to the nearest inch, the most I can be off by is a half an inch. That's your max error for a single measurement. So what I'm going to do is I'm going to take each one of these measurements and take off a half an inch. So 11.5, 5.5, and 4.5, and find out what's the volume of that. 284.625 cubic inches. So that's the minimum volume. If I measured off a half inch on each thing, that's the lowest the actual volume could really be. Maximum volume, I'm going to add a half an inch to each number. So 12.5 times 6.5 times 5.5 is 446.875 cubic inches. Now I need to compare these numbers and find the differences. So the minimum, the absolute value of minimum minus measured will tell you how far apart these numbers are. 75.375. That's how far we were off with the minimum volume. If we subtract the maximum and the measured, take the absolute value, 86.875. That's how much we were off on maximum volume. Well, which one is further away from the measurement? So the greater difference is the one that's going to get us the greatest possible percent error. So we're going to do greatest possible percent error is greatest difference in volume divided by measured volume. 86.875 divided by 360 is about 0.224, which is approximately 24%. So the greatest possible percent error, if we made the worst measurements of possible, would be about 24%. So pause and see if you can do this. I'm telling you, the finish line is real close. What if they were measured to the nearest half inch? Well, I remember that my measured volume was 12 times 6 times 5, which was 360 cubic inches. If I'm measuring to the nearest half inch, my maximum error in a single measurement would be 1/4 of an inch. So my minimum would be if these were all short 1/4 of an inch. So that would be 11.75 times 5.75 times 4.75. What's my volume? 11.75 times 5.75 times 4.75 is 320.921875. 921875. So this is 320.92785. That's what it was, right? It was 921.875. You should have said something. Now, for my maximum volume, I'm going to add 1/4 of an inch to each measurement. 12.25 times 6.25 times 5.25. 12.25 times 6.25 times 5.25 equals 401.953125. 953125. 401.953125. Did I do that right? I did do it right that time. And you tried to call me out again. Okay, so let's find the differences. Absolute value of 360 minus 320.921785. 360 minus 320.90210 921,785 is 39.08. I think I can round now, can't I? And then for this one, absolute value of 360 minus 401.953125. 360 minus 401.953125. So the absolute value would make it positive, 41.95. This one's greater. Greater? Is that an E or no? I don't know. Put it in Word. Email me. Let's see. Now let's find the percent, the greatest percent error. So the greatest error could be 41.95. So out of 360, 41.95 divided by 360. That's approximately 12% error. So, cool, 12%. That's better than the last percent we did. And you're done. Congratulations, you made it. How many times did you pause? I hope you paused a lot. I'll talk to you later. Bye.